So now we see the Moseley's equation, so which is given by Moseley in his experiment called Moseley's experiment, which was given the introducing of atomic number concept. So now we see the Moseley's experiment and its equation and the related problems. Okay. Now see the what is Moseley's experiment and what is the equation belonging to that experiment. So Moseley's equation. So Moseley's equation actually depends on, it is given in Moseley's experiment. So what was Moseley's experiment? So we know that Moseley introduced a new concept, that is atomic number. Just at the age of 25 years, he was treated as a young scientist. Just at that time only, he introduced the new concept, that atomic number, and proved that atomic number is the more fundamental property of elements, which totally collapsed the concept of atomic weight given by Mendeleev and other scientists. Now we see the Moseley's experiment. So what was the Moseley's experiment? He passed cathode rays. He passed cathode rays on the elements. And by the passage of cathode rays into the elements, they emitted X-rays. Now, the X-rays emitted by the elements are passed on a photographic plate. And there is a formation of some lines takes place. So this is called spectrum. This is called spectrum of this X-rays. Means this spectrum, this lines spectrum of X-rays gives the characteristic of these X-rays which are emitted by this element. So, how this element released the X-rays? By passing the cathode rays from it. So here, the cathode rays, he passed the cathode rays into the all elements which are discovered at that time. So at that time low, so the available elements he done the same experiment. He done the exactly repeated exactly same experiment for all elements which were discovered at that time. The experiment is, he passed the cathode rays through the elements, through the all elements. He done the experiment repeatedly for many times by taking equal mass, and all elements releases X-rays. Thus, to know the X-rays, for the study of the X-rays, he used a photographic plate which captures the spectrum of that X-rays. Means, by analyzing the X-rays spectrum, he was able to know some properties of X-rays. And he observed that ఇక్కడ ఫామ్ అయిన ఈ ఎక్స్రేస్ ఒక్కొక్క ఎలిమెంట్ నుంచి వచ్చిన ఎక్స్రేస్ లో ఏం డిఫరెన్స్ ఉందంటే దేర్ ఇస్ ఎ డిఫరెన్స్ ఇన్ దేర్ ఫ్రీక్వెన్సీ. అన్ని ఎలిమెంట్స్ ఎక్స్పెరిమెంట్ చేసినప్పుడు దే రిలీజ్డ్ ఎక్స్రేస్. అయితే ఎక్స్రేస్ కూడా మనకు ఒక డిఫరెంట్ రేంజ్ ఉంటుంది, ఫ్రీక్వెన్సీ రేంజ్, వేవ్ లెంత్ రేంజ్. సో all elements released X-rays range only, but in that range they are having different frequencies. How he observed the different frequencies means by the help of the spectrum of these X-rays emitted from different elements, and he observed the frequency of the X-rays emitted from elements, and he studied the X-rays with the help of this X-ray spectrum, and by analyzing this X-ray spectrum, Moseley was able to calculate or measure the nuclear charge of atoms of that particular elements. ఇవి వచ్చిన ఎక్స్రేస్ స్పెక్ట్రమ్తో అనలైజ్ చేసి, సో వాటికి వచ్చిన డిఫరెంట్ ఎలిమెంట్స్లో ఉన్న ఆటమ్స్లో ఉన్న న్యూక్లియర్ ఛార్జ్ను he was able to calculate with the help of his experiment. And he said that the nuclear charge is the fundamental particle. The nuclear charge is the fundamental property of elements, and the nuclear charge nothing but treated as Z, or nothing but it is equal to atomic number. So this was the Moseley's experiment, and he also given an equation to explain all these observations. Is called Moseley's equation. The Moseley's equation is root 2 is equal to A into Z minus B. So this is called the Moseley's equation, in which nu is equal to frequency of X-rays emitted from elements. What is A? So A, B are constants which depends on nature. Their value is not exactly constant for all elements. They are constant for each and every element differently. Means this constant value depends on nature of elements. These A, B values are constant, but they are constant for each element separately. If their values are different from one element to other element, their values depends on nature of that element. So then Z is a nuclear charge, nothing but the nuclear charge of that elements, which was treated as atomic number. So actually it is also given that the root 2 is always proportional to it also given that root 2 into 10 power 8 value is proportional to Z, but mostly just it is modified as root 2 proportional to Z minus B. Mean here B is also known as screening constant, and root q is equal to a into z minus b. Here a is simply proportional constant. Is proportionally constant. Okay. So see the graph for this equation now. So here root q equal to az minus ab. So this equation can be compared with y equals mx minus c type of equation, which is a equation of straight lines. X-axis, y-axis. So on the y-axis take root nu, on the z-axis, sorry, on the y-axis root nu, on the x-axis z is taken. In the place of m there is a. Here m indicates slope of that line and c indicates intercept. Here in the place of c there is minus ab present, means there is a negative intercept. Here there is a slope is equal to a, so that is the equation can be like this. So this is the intercept. This is angle generally equal to 45 degrees. So this is called the Moseley's equation. So in some areas it is also given that so like this. This is also is the correct one. If you extrapolate this, we will get like this, which is equal to this. The actual one is this one. We need to use this graph in the calculations also. Okay, this is the Moseley's experiment and Moseley's equation, which is useful in the calculation of atomic number, nothing but in the calculation of nucleus charge, by knowing the frequency in his experiment, frequency of that X-rays released in his experiment by elements. He was able to calculate the nucleus charge, means by knowing the frequency of X-rays emitted by the element and these constant values, we are able to calculate the atomic number, nothing but the nuclear charge, the positive charge present in the atoms of that particular element. Okay, this is Moseley's equation. So now we see some problems related to this Moseley's equation. Okay. Okay, see the first problem. So in the graph between root nu and z, in the Moseley's equation, the intercept is given, that is 1. So actually the intercept is given in terms of minus generally. It's minus 1 on the root nu axis. Nothing but generally we take root nu on the y axis. So we need to find the frequency of that X-rays when atomic number of that is 51. Okay. So we know that the Moseley's equation means so root nu is equal to z minus b. So the root nu is equal to az minus ab. Here intercept is given, the intercept ab, so nothing but So the intercept value you can say OX. The OX value is given as -1. So the here AB is equal to given as -1. So here we need to find Z atomic number. Atomic number is also given 51. Z is equal to 51. We need to find the frequency. So we have to find new value. Okay, just substitute in it. So what is the A? A equal mean we know that the A is equal to slope. Slope is always taken as tan theta, which is equal to tan 45 degrees, that is equal to 1. Here now root nu is equal to A1. The atomic number is given as 51 minus AB is equal to another -1, so that becomes +1. The root nu is equal to this +2, and the nu is equal to 52 square. So it is approximately 2550 second inverse. We are taking here approximate value, not exact value. Let's take the problems in notes. So we must practice the problems in this class, and also related problems in this book, in your book, means your reference book. You must show these notebooks in the school. Afterwards, we will check the notes. All such check your notes of these online classes. Okay. Okay, see the next one. Here also the problem is similar to the earlier one, but in the earlier one we calculated the frequency. But in this problem the frequency is given. We need to calculate the atomic number. There is nothing but we need to calculate the Z. Okay. See the problem. See the graph between root nu and Z. So which indicates the Moseley's equation. The intercept is given as -1 on root nu axis, that is always on y axis. We need to find the frequency of that X-rays emitted that element is that 600 second inverse is given. So we need to find that so atomic number Z of that element. So we know that equation root nu is equal to 2Z minus B. Similarly, root nu is equals AZ minus AB. Here nu is given as that 600. So what is A? For A is always we know that is equal to tan 45. This is X point. The intercept is given as -1. Here it is always 45 degrees. So therefore slope equal to A is equal to tan 45 degrees equal 1. So 1 into Z. We need to find the Z. So minus AB. AB is given -1. So that is equal becomes +1. So root 100 means it is equal to 60 equal Z plus 1. Therefore Z equal to 60 minus 1, that is equal to 59. So the atomic number is 59. Nothing but what is the quantity of the nuclear charge. So how many number of the unit positive charges present in it is also equal to 59. Okay. So it is again it's based on Moseley's equation, but in this problem we need to calculate the intercept of the graph. Okay. So here the given values are 1600 second inverse of frequency is given. The frequency is 1600 second inverse, and arbitrary number z is also given. Now we need to find, there is three problems are there. Find the intercept. Intercept in the graph, we know that we need to find out this OX intercept. So slope always we know that so what is the Moseley's equation? Root mean is equal to maybe root nu means that is root 1600. A is nothing but tan 45, means the value of constant A slope equals tan 45 degrees equal to 1. So there is 1 into this equal 1. The Z value given as 39 minus AB. So we need to find this AB value. Okay. So root 1600 means that is equal to 40 equal 39 minus AB. So that is minus AB is equals 40 minus 39. So the intercept AB is equals minus 1. And this is the intercept of a straight line is minus 1. And we also calculated already the value of constant A, the slope is equal to 1. Next we need to calculate what is the value of constant B. Okay, constant B calculated. So we know that AB is equal to minus 1. Here we got that intercept AB is equals minus 1. Already we know A value is 1. So that is 1. So B value is minus 1. Okay, so these are the problem related to the Moseley's equation. So maximum these three models are only repeated in your any reference book. Just do the all calculations of problems of this class and also in the reference books. We compulsory check these all problems in classroom. Okay.